and welcome again to Math Counting. So last time we spoke about limits at length, and then this time around we are moving into differentiation. I remember when I started the limits, I spoke a little bit on the introduction of differentiation and even integration. So in this video, we are going to go into details of differentiation. All right, so I remember in the last video, I spoke about differentiation simply being finding the rate of change of a function or finding the slope of the curve of that function, right? So let's say you have a curve y equals, say, f of x that looks like picture A, right? Now, say we have a point at A where the y component is f of A, right? We can simply find the slope of this curve by choosing a point in the neighborhood on the curve. So let's say we choose Q, right? If we choose Q, then we have 2 points. So to find the gradient of this line that cuts 2 points on Q, all we have to do is we know the formula for gradient. So we know that m is equal to y2 minus y1 all over x2 minus x1, right? All right, so we can say that the gradient m, which of pq will be equal to f of x minus f of a all over x minus a. Right, so this is the gradient formula, right? Now, this line right here is a secant line. Now, what happens if we study or if we move Q towards P? Okay, the more P approaches Q approaches P, we see that we move from Q1 to Q2 to Q3. And clearly, the second line is beginning to look like what? A tangent line. So that means if we take limit as x approaches a of the function f of x minus f of a all over x minus a, we will find the gradient of the tangent instead of the secant. So MPQ now becomes this. Right. So now let's take a quick look at a simple example. Say we have a point. Let's say we have a function. We have a function f of x equals x squared, and then we have a point, say, 1, 1. And then we have to find the equation of the tangent line to the curve. All right, so now we've been given a point on the curve, right? So we can simply pick any point in the neighborhood, okay? And so we can have the gradient being equals to the limit as x approaches 1 of the function f of x minus f of 1 all over x minus 1. But we know what f of x is, right? So we say that m is equal to limit as x approaches 1. F of x is x squared minus 1, because f of 1 is 1. Obviously, from the point, if x is 1, then f of x is 1. So we have x minus 1. Now, let's look at this function. If we insert x to be equal to 1 into this, we get an indeterminate form, right? We are going to get the denominator to be equal to 0 here, So what do? We can simply simplify this function here, right? And say that for the numerator, we have difference of two squares. So this is the same as saying x minus 1, x plus 1, all over x minus 1. So we can cancel out this, and then we are going to have m to be equal to limit as x approaches 1 of x plus 1. And that gives us 1 plus 1, which is equal to 2. Perfect. So now we have found the gradient of the tangent line. Now, we can use the point-slope form of the equation of a line, which reads y minus y1 is equal to m times x minus x1. So now we can basically use the point we were given, which is 1, 1, and then our newly found gradient, which is what? 2. So we can say that we have y minus 1 equals 2x minus 1. Then our y will be equal to 2x plus 1, right? Oh, no, sorry, minus 1 rather. Okay, now that being said, let's look at this scenario. Now, if we have, say this is a road, okay? Now, we are standing here on this part of the road called X, right? And then we move from X to another point, say Y. All right? Now, clearly, to move past X and then reach Y, it means I have to cover an extra distance, right? So I can say Y is equal to where I stood at X, right? Plus some distance H. So, which implies that the distance between X and Y is H. Right? So, if I want to find the difference between the two distances, okay, I can say this distance right here is equal to what? X plus H minus X. Sorry, minus X, right? Good. So now if I want to find the rate at which this distance is changing with respect to time, I can simply say that if I find f of x plus h minus f of x all over t, this function right here, sorry, all over h, this function right here is giving me what? The rate of change of distance. Okay? And this is how we calculate velocity. Now, we can clearly see that this formula is a replica of what we did earlier. Now, consider this as the point x in the previous example. Here, so if this is a in the previous example, and this is x, where this is x and f of x, then the distance right here is h, right? So x is equal to a plus h. Okay, so to write the gradient formula from here, we can say that m is equal to, so sorry. So we can say that m will be equal to f of a plus h minus f of a all over h. Right? So basically, these two are the same. Okay? So now, remembering that statement, that to find the derivative simply means to find the slope of the curve, let's consider this simple equation. Say we have the function f of x equals x squared minus 8x. Now, using the gradient formula to find this, we have to find f of a plus h, and then f of a. Now, what is f of a plus h? So f of a plus h, simple, we have to, anywhere we see x, we put a plus h, okay? So we are going to say that a plus h squared minus 8, a plus h plus 9, and then we have a squared minus 8a plus 9, right? So if we simplify, this is f of a, sorry. So we can basically put them together and say m equals limit as h approaches 0. So I'll explain why I write h approaches 0. So you see that as we send q closer to p, the distance right here, which is h, begins to close up. So if this is a and this is x, so this is our new x, right? And here, another new x here. So the distance begins to close down. So as q approaches, as x approaches a, h approaches 0. Because the gap between a and x begins to close as we move to the left. Great. So we have a squared plus 2ah plus h squared minus 8a minus 8h plus 9. So minus a squared plus 8a minus 9 all over h. And this simply gives us, let me take your time and do the simplification, and you realize that you have lim as h approaches 0, 2ah plus h squared minus 8h all over h. And this in turn gives us, so we can bring out h obviously, and then we have 2a plus h minus 8 all over h, and then we have h going away, so we then have limit as h approaches 0 of 2a plus h minus 8, and the answer is 2a minus 8. Okay. Now, if you have had any prior experience with differentiation, you will realize that if we simply apply differentiation of polynomials, we know that since f of x is equal to x squared minus 8x plus 9, f prime of x is going to be, we bring the 2 here, x 2 minus 1 is 1, minus 8. And this is the same as this. So this goes a long way to prove that, the gradient of the curve is basically the derivative of the function. So we'll end it here and then continue with more examples on finding the derivatives of different types of function. Thank you and bye-bye.